Alright, today we're going to learn how to divide polynomials. First, before we do that, let's think back going old school. Old school. Think about when you first learned how to divide. You had these things here, this long division symbol, right? Remember you had this would be like 50 divided by 2, right? So you would say, what times 2 will give me 5? Or how many times will 2 go into 5? Well, 2 goes into 5 2 times, right? 2 times 2 is 4, right? And then you would do 5 minus 4. 5 minus 4 is 1. And then you would bring down your next number. Now we have 10. And you would say, how many times does 2 go into 10? Well, 2 goes into 10 5 times. 5 times 2 gives me 10. And then we would subtract it, right? 10 minus 10 would be 0. And then that's how we did it old school. When you first learned about long division, way back in like 3rd grade. Alright? So let's try another old school problem, alright? We have 54 divided by 3. Alright, well, how many times does 3 go into 5? Well, it goes into it once. 1 times 3 is 3. And then we would subtract. 5 minus 3 gives me 2. And then I would bring down my next number, that 4. And then, if I'm continuing on the old school method, I would say, how many times does 3 go into 24? Well, 3 goes into 24 8 times, because 8 times 3 gives me 24. And then I would subtract, right? 24 minus 24 is 0. Alright? Pause the video and see if you can do this last example over here, this 1C, by yourself. 54 divided by 2. See if you can do that one on your own, doing the old school method. So pause the video, unpause it when you're done, see if you got it right. Alright, hopefully you paused the video. Let's see how you did. 54 divided by 2. So I say, how many times does 2 go into 5? It goes in there twice. 2 times 2 is 4. 5 minus 4 is 1. Bring down that next 4, and I get 14. How many times does 2 go into 14? Well, it goes in there 7 times. 7 times 2 is 14. 14 minus 14 is 0, so my answer was 27. Alright, so remember way back then when we learned long division? You're probably wondering yourself, why are we doing this? Well, we can divide polynomials doing them by long division. Alright, what we can do is like this would be x squared plus 7x minus 30 divided by x minus 3. We can rewrite that as a long division problem, and that could be one way we can solve to get the answer to this polynomial question. Remember, what you're dividing by goes on the outside. So if I'm dividing by this x minus 3, right? So that goes on the outside. What I'm dividing goes, this x squared plus 7x minus 30 goes on the inside, right? So that's something to remember. All right, so let's go old school method on how to divide polynomials. All right, so I look at this here. I see x, and I say, what times x will give me x squared? Well, x times x will give me x squared. X times x will give me x squared. But now I have this minus 3 here. I have to do something with that. Well, I have to do the same thing. I do x times minus 3. So x times minus 3 is minus 3x. Right? So now I subtract, just like how we did up here. Right? Just like how we did in our long division problems up there. X squared minus x squared, those cancel out, which is what we want. 7x minus negative 3x. Well, I know if I minus a negative, I have to do the keep change, right? So 7x plus 3x now will give me 10x. And just like my long division, I bring down what's left over. Just like how up here we brought down that 4, right? Same thing with these. You bring down what's left over. So now you say to yourself, what times x will give me 10x? Well, that would have to be a positive 10. Positive 10 plus x will give me 10x. And then I also have to times that by my negative 3. 10 times negative 3 will give me negative 30. And now I subtract. Yay! 10x minus 10x cancel out. Yay, that's what we want. Negative 30 minus negative 30. Well, I know I have a minus a negative, so I have to do keep change, right? Negative 30 plus 30 gives me 0. And that's exactly what I want. So now this number up here is our answer, just like how the number up here we circled in green was our answer for our long division problems. So our answer would be x plus 10. That is our answer. Another thing, a good thing, is that we can times this by this x minus 3 and check our work. If I wanted to times this, and I would do FOIL first, x times x is x squared, outside, x times negative 3x, inside, 10 times x is 10x, last, 10 times negative 3 is negative 30. And then I would combine my like terms, and the good thing about FOIL is my like terms are always in the middle. So negative 3x plus 10x is 7x, and I can't combine that minus 30 with, so I bring it down. And this right here gives me the same thing that we started with. So I know we got it right, and this is our answer, x plus 10. All right, let's try another one. All right, in this example, I have 2m squared minus m minus 3 divided by m plus 1. So now I can rewrite this in the old school method. So what I'm dividing goes underneath that 2m squared minus m minus 3. And what I'm dividing by, that m plus 1, goes on the outside. So now I think to myself, what times m will give me 2m squared? Well, I know 2m. 2m times m will give me 2m squared. Now I also have to do 2m times this 1. 2m times 1 would be positive 2m. And now I subtract. 2m squared minus 2m squared cancel out. Negative m minus 2, remember this is really negative 1, so negative 1 minus 2 is negative 3m. And then I would bring down what's left over, that minus 3. So now I think to myself, what times m will give me negative 3m? Well, that would be negative 3. Negative 3 times m is negative 3m. Negative 3 times 1 is negative 3. And now I'm going to subtract down. Negative 3m minus negative 3m. Well, I know minusing a negative is the same as adding them. So this would really be negative 3m plus 3m, which cancels out, which is what we want. Now I'd have negative 3m minus negative 3m. Same thing, two negatives or minusing a negative is the same as adding. Keep change rule. Negative 3 plus 3 gives me 0, which is what we want. So our answer will be 2m minus 3. That is the answer to our division problem here. 2m minus 3. And if I wanted to, I could take this original binomial that we divided by and multiply it by this binomial that we just solved for. And if I do that using FOIL, I should be able to get this original polynomial. All right, let's try a different method I'm going to show you. All right, another way to divide is we can divide using factoring methods. We can divide using factoring methods. So what do I mean by that? All right, so remember when we factored, we took this number on the front and we multiplied it by that number in the back, right? So 1 times 12 would be 12. And then we took that middle number and we put that down here on the bottom, right? And we said what times what gives me 12, but adds to give me 8. Well, 12 times 1 gives me 12, but doesn't add to give me 8, so it doesn't work. I see it's even number, so I can divide by 2. 6 times 2 gives me 12. 6 plus 2 gives me 8, so that works. It'd be 6 and 2, right? So then we can use our box method. I can draw my box. And then I would put my first term, that x squared, in my first box, right? And then my 12 in my last box. And then I have 6 and 2, so I'm going to put 6x and 2x in my other boxes. And then I want to put this, what I'm dividing by, on the side of one of my boxes. So this is x plus 2. I'm going to put that on the side of my box. X plus 2, or on top of my box in this case. And I put it on here because I see this is a 2x here, so I like having the 2 right next to it. So now I got to find what this other side over here is, and that should be an answer there. So I say, what times x gives me x squared? Well, I know that's x. And then x times 2 gives me 2x, so that works for that box too. So now I say, what times x gives me 6x? Well, that would be 6. And 6 times 2 gives me 12, so that works for that box too. So my answer for this would be x plus 6. Alright, to show you that it could work either way, here's the old school long division way. So long division bar, I put what I'm dividing in the underneath. I'm putting what I'm dividing by on the side. I say, what times x gives me x squared? Well, that would be x. X times x is x squared. And then I have to do x times 2. X times 2 is 2x. And then I would subtract, right? X squared minus x squared cancels out. 8x minus 2x is 6x. Right? And then I would go on. So what times x gives me 6x? Well, that would be 6. 6 times x is 6x. Oh, I forgot to bring down the 12. So let's bring down the 12 first. Sorry, should have done it earlier. We all make mistakes, right? Now I do have to do 6 times 2. 6 times 2 is 12. And then I would subtract, right? 6x minus 6x cancels out. That's exactly what we want. 12 minus 12 is 0, which is exactly what we want. So our answer is x plus 6. So no matter which way you do it, you get the same answer. And remember, we could always take this answer and multiply it by our original polynomial over here. And when we do FOIL, we should get this starting polynomial. Alright, let's do one more. I want you to try it on your own first. Let's pull it up. Alright, so look at this one. It says 3x squared minus 16x plus 21 divided by x minus 3. I want you to pause the video, try it on your own. Alright, you can either do the old school long division method, or you can do the box factor method. Doesn't matter, you'll get the same answer. Unpause it when you're done, check your work. Alright, let's see how you did. So I go do my long division. 3x squared minus 16x plus 21 divided by x minus 3. What times x gives me 3x squared? Well, 3x. 3x times x is 3x squared. 3x times negative 3 is negative 9x. And then I subtract. Those cancel out. Negative 16 minus negative 9 is the same as adding. Negative 16 plus 9 is negative 7x. And then I bring down what's left over. What times x gives me negative 7x? Well, that would be negative 7. Negative 7 times x is negative 7x. Negative 7 times negative 3 is positive 21. And now I subtract, right? Negative 7x minus negative 7. Well, minusing a negative is the same as adding. So negative 7 plus 7 is 0, cancels out. Now I have 21 minus 21, which is 0. So my answer would be 3x minus 7. All right, hopefully you did well on that. If you have any questions at all, please feel free to email me, and I will see you later.